All right, now we're going to talk about like terms. And like terms are very important. This is one of the things that we'll use all year long and all throughout your entire math career. And it causes problems for people. I don't really know why. Think of it like I've got 3 apples in one basket, 2 apples in another basket. How many apples do I have altogether? I've got 5. 3 apples plus 2 apples is 5 apples. I'm just counting how many apples they are. Now, the problem here is sometimes people get messed up when I have 3 apples and 2 very special apples. Notice how that second term has an a squared in it. Because it does not have the same exponent as the other variable, we don't combine them together at all. This is as simplified as that expression can get. Because they're 2 different things. A is different than a squared. So they don't get to combine together and play at all. So you have to have the same variables with the same exponent. And when you finish this all up and you get them all together and there's no parentheses left, you've got yourself a simplified term. So both those box answers there are the simplified term. And sometimes they'll give you a problem that you can't simplify at all, just like this little example here that I gave you. And that's okay. All you have to do is just say, already in simplest form. So here I'm going to simplify 17u plus 25u. Basically what I'm doing is trying to count how many u's there are. Here there's 17, here there's 25. I add them together and I get 42 u's. Now you might be asking, why am I learning this in the same section as I'm learning about the distributive property? Well, what's happening here in this problem, which we kind of gloss over because we can just think of it like counting, is the u is being multiplied by both of these 2 parts, which means it's been distributed. So we can undistribute it and get 17 plus 25 times u. See how that's the same as a distributive property, just in reverse? That's where this all comes from. So, and that's where all this simplifying comes together. Next up, here I've got 6t squared, 3t, and negative t. One thing I like to do is I like to, especially if it's a really big long one, like you get like towards the end of Algebra 1 or in Algebra 2, sometimes you get stuff that like it takes 2 lines on your paper to write everything out. I'm going to underline everything that has this, that's got matching variables and powers. Like here for the 6t squared, that's a t squared, it's going to be green. For the other ones, it's just a normal t, they're going to be red. I can only combine together the red terms because they have the same variable with the same power. So the 6t squared is just going to stay alone how it is. 3t minus t, 3 minus 1 is 2t. And I'm going to add them together. And that is the simplest form. Now, one thing that I don't know if I've mentioned it yet, maybe it's come up in the discussions in the class, but if your variable ever does not have a coefficient on it, its coefficient is 1. If it's ever a negative of that variable, that just means that the coefficient is -1. We just don't write it because mathematicians are lazy. All right, and the coefficient here is this number that's being on the outside. That's the coefficient. All right, I'll say that a lot. You definitely got to know what that number is. It's not the t, it's the number being multiplied by the t, or whatever variable we're using. All right, example 5 in the next video.